Good evening, ladies and gentlemen. I'm Dilan Tilang from Building Service Engineer Sectional Committee. On behalf of Building Service Engineer Sectional Committee, I welcome you all for the 7th webinar we conduct in session 2021-2022. Extra low voltages or ELV systems are essential services in modern buildings. I believe many of this audience is from building services sector, and you might be aware that in the very past, ELV systems used to be with separate infrastructures for individual systems. As time passed by, IP-based technologies were developed well, and IP-based ELV systems also came into action while the systems were sharing a common IP-based infrastructure. Public address systems, etc., are now available in IP basis. The most interesting thing about these systems is that it's never the final version. They are evolving continuously. The technology evolving continuously. Therefore, as engineers, we have to be always in touch with such advancements to get the best solutions for our stakeholders. Therefore, for the benefit of us all, we intended to present the webinar today under the title of IP-based ELV systems for building services applications. Our distinguished resource person today, Mr. Sashika Surain, is a product of School of Computing of the University of Colombo. He also completed his postgraduate studies too in the same university. Currently, he's attached to Axiata Digital Labs as the architect for development, security, and operations. He's also contributing to many prominent universities locally and internationally as a visiting lecturer on various IT-related subjects. During his career in the last 13 years, he has served many organizations in different scales, such as systems engineer, principal security engineer, etc. We warmly welcome Mr. Sashika, and we muchly privileged to have Mr. Sashika with us today to present this webinar. Before moving to the lecture, we would like to let you know that there's a Q&A session after the presentation. Q&A session will be moderated by our moderator, Mr. Jagatlal Vikramasekara, one of the key specialists in ELV systems today. Therefore, should you have any questions or clarifications, you can drop those into our chat box by selecting the moderator in the chat box. The moderator will direct those towards the research person. With that brief, let's move toward the webinar today. Mr. Sashika, it's over to you, sir.
Thank you very much, Dilan. So, hope everyone can hear me, and I'll just start the video, but unfortunately I'm in the power failure. So don't think that you cannot see my face properly. So, but still, so good day to you everyone, guys, and we will be going to discuss today one of the important chapters about the internet protocol. So I'm Sashika Surain. So we will be discussing a few interested areas here, and let's moving forward with the what we trying to be in power today. So basically, we will be trying to understand what is the IP address, why it is really required, and what kind of trends in the IP technologies that we are right now facing. And then again, moving forward, we will be going to discuss about the why the IP which is used for the ELV system, specifically access control system and the Cctv environment, and what kind of advantages, and obviously if there is a technology, definitely that will be having disadvantages as well. So we'll be just reaching out the disadvantages also, and the main risk that we are having with the IP technology that obviously we are going to start it. And one of the important things like how we will be going to select the devices, and as well as the troubleshooting on the IP-based environment, and what kind of best approaches that we are going to deal when you are installing any kind of ELV system into our environment. So these are the high-level things that we are going to cover within this particular 2 hour time period. So let's move into the internet protocol. So very first thing, what you really need to understand is we'll try to understand with the layman environment. Since this is IT, like you are in the construction engineering environment, so it's a two different expertise, obviously, and but obviously as a construction engineer, you should really require to understand these concepts because when you are going to install any kind of building security system, so obviously you must need to deal with these internet concepts, IP protocol, IP, basically internet protocol, or rather we call it as IP. When you want to talk, basically, let's start with the layman understanding. So when you want to talk to each other, obviously we should know the language, and then again we have the mouth to talk. So the two things have to be satisfied, language and you have the physical devices, basically the physical devices now. But the communication mechanisms which we are using here is the language. When you are going to deal with the network environment also, if the two devices require to deal with, or if they really require to communicate in between those two devices, we should have the concept called or the protocol called or rather algorithm called IPv4. So, or rather we do have the IP. So hope you can hear me very clearly, or do you have any issues in here?
Yeah, I think your voice is breaking up, Suren. So
Is it okay now?
certainly okay now, but we lost you for a few minutes earlier.
Okay, sorry guys. So just again, I'll just recap what we have discussed so far. So whenever you want to talk to each other, like in layman environment, obviously what you really need to understand here is you should have a uh, language and as well as the device called mouth. So when you want to talk to each other, definitely we have two things. So the language is the main protocol here we are using because we should have a common language, common understanding to make the communication crystal clear in between those two parties. Similarly, when you are going to deal with the device communications also, you must need to deal with the same thing. You should have a way to communicate. Of course, the physical devices are there like network interface card or rather we call it as NIC, and other devices also will be there. But main thing here is you should have a protocol or language. Here we have two kind of protocols or language, IP version 4 and the IP version 6. We'll discuss further in the IP version 4, but we need to understand whether the IP version 6 is really required. The reason why they have introduced two different protocols here is the major thing here is when you are going to deal with the IP addressing, basically this IP version 4 is basically your IP version 4 is 32-bit address space. 32-bit address space. So the 32-bit address space in the sense, 32-bit address space in the sense, the number of IP addresses we can create. That means we are dealing with the two-base mathematics, so 1 and 0. So the 32-bit address space in the sense, it's basically having 2 to the power 32 IP addresses. 2 to the power 32 IP addresses in the 4 billion IP. Altogether in the IPv4 address is 4 billion. So if you if you look at the world population today, just take the two largest nations, China and India. Obviously, they are roughly close to the 3 billion. So 1.3 and 1.45 in the China. So they roughly close to 3 billion. So if you get together the world largest five nations, like Bangladesh and then even Pakistan and USA. So obviously that is more than the 4 billion uh, people. So even if you take average persons, they do have at least two devices which are getting connected to the internet at the same time. So for example, in my case, I have one phone and this particular laptop will be connected into the internet at the same time. So if you consider the number of IP addresses which we really need to consume, is like double the space. So 8 billion. So actually, we really require to double the space. So the IPv4 is not capable of providing that capacity. That's why they have introduced the IPv6. This has been introduced like actually the communications and then the research has been started since 1990, but actual implementation has been started since 2000 onwards. But in Sri Lanka, we have adapted the IP version 6 into our environment since 2010 onwards. Still, if you look at the entire IP version adaptation rate is just above 1%, below the 3% actually, in between 1 to 3%, which we are running right now. Therefore, of course, when it comes to you, the ELV system, of course, you don't want to worry about the IP version 6. The reason why, still they are dealing with the network level also we are still dealing with. So we need to build several capacities, expertise on the IPv6 environment, which we actually lacking behind those things. So therefore, we really don't want to worry about IPv6 for your scope actually, the ELV system. The but keep in mind these devices have been enabled IPv6 as well. So if anytime if you want to consider of configuring the IPv6, of course that is available on any kind of devices when you are purchasing out from the market. So that is the most important thing that you need to understand here. But in our case, what we will be really focusing here in the IP version 4, because the IP version 6 is still in the developing stage into our network environment. So if you look at this IP version 4 protocol or any IP version internet protocol, we can simply map to the post office operation in any environment. Because the post office operation is very much similar to the TCP/IP stack or the network stack in the technology level. So what we really going to do here is, whenever you want to send the postal mail. So basically the postal mail should address the destination. So we have a source and the destination. In layman, in simply, when you write it down the addresses, we will be putting Apasu Yayitu. So basically that is it. So Apasu in the sense it's the source address. The Yayitu in the sense that is the destination address. So in similarly, we have a source IP address, we have destination IP address. Keep in mind, we cannot have one single postal mail address to the two different devices, two different houses basically, two different houses. The reason is it's a conflict. Then the postman and the delivery will be in a conflict where which house we need to send, which house we need to send. So that is there. In IP address also, we cannot have IP conflict. If we do have the IP conflict, those two devices, let's say we have mistakenly put the same IP address into another, those two devices will not properly communicate with the other devices. That is quite clear. So similarly, that's why I told you it's exactly same to the post office operation. Exactly same to the post office operation. So this has to be, your postal mail address has to be identical, as well as your IP address which you assign to the devices definitely has to be identical. It cannot be duplicated, because if it is duplicated, so they cannot exactly find the way to which house exactly this particular message will go. So that is the exact similar thing. So that's the simple understanding on the IP protocol. We have to have a source IP address. We have to have a destination IP address. So the source IP address in the sense is the sender in the technological term. The destination IP address in the sense is the receiver. The sender and the receiver. That's the simple understanding on the internet protocol. So when you look at the IP addresses, so basically the IP address contains two things, the IPv4 specifically, the private IP and the public IP. It's like this. Whenever you are in a village, sometimes your house will be identified by some a nickname or common name which is given by the villagers, the neighbors basically. Let's say, for example, birthday. So if someone within your premises, in your village area, if someone wants to reach to the birthday together, obviously they know how to reach it. Because those are the neighbors. But if the postman, if we put it in the letter birthday together, the postman does not understand where this is exactly located because it does not have any identification, the fruit and those things. So the private IP is a similar. Private IP in the sense, in order to communicate within your premises, we can use the private IP address. Public IP is in the sense, if anytime, if you want to connect with the internet, if anyone wants to connect your devices through the internet, of course, you need to have a public IP to your devices. The public IP, which we are not going to discuss because that will be basically assigned by the ISPs, internet service providers like Telecom, SLT, Mobitel, Dialog, you name it, whatever the telecom providers or the internet service providers will responsible for assigning the IP addresses to your routers. From the routers only, we are getting that particular public IP. So therefore, we don't want to specifically when you are configuring the ELV system, you really don't want to worry about the IP addresses. That is, of course, nothing to deal with the public IP. So basically, the next thing is what you really need to understand here is right. So basically, what you really need to understand here is the private IP is the most important thing, sufficient, like most important thing for your internal communication. You don't really want to worry about the public IPs because that is actually handled by the ISP. So when it comes to the private IPs, the private IPs basically let you know the most common private IPs we are using within our environment. So most of the times those are started with the 192.168. See here, I'm not going to discuss about the structure of the IP address at this moment, but normally, as I told you, it's containing 32-bit address space. The way that they have designed the IP addresses, so into 8-bit portions. So you can see this particular part is 8-bit, this particular part is 8-bit, this particular part is 8-bit, this one is 8-bit. So 8-bit into 4 sections, so it's a 32-bit IP address. So basically, the private IP addresses will contain 192.168. Any IP address which are starting with the 192.168, those are private IP addresses. 192.168.1, 192.168.2, 192.168, any IP address. Then 10 range IPs. Any IPs which are starting with the 10, that is private IPs. Then again 172.25, 172.25. If the IP address starting with 172.25, 172.24, 172.16. So those are 172.17, 172.18.
those are private IPs. But there are, just keep in mind, there are certain set of IPs even in the 172 range, which are actually public IPs. So we are not going to use it. But anyway, in your case, you can satisfy, you can use the 192.168 IP addresses for your entire environment. So that is guaranteed because those are private IPs. No one can, like, you will be used only within your premises. Let's say, for example, if you are using uh, ELV systems for your for particular building, of course, nothing to worry. You can use the 192.168, one range IPs, 192.168.2, 192.168.3. Likewise, you can use the IP addresses. So I'm like recommending you to stick with the 192.168 IP address ranges. So nothing to worry about it because you can survive with these IP addresses. But the most important thing here is when you are going to decide the IP address, what kind of IP addresses like which we need to use. The most important thing here is you must need to get the number of devices which are going to getting connected. So then only once you finalize the number of devices, like how many number of CCTV cameras, how many number of access control systems, how many number of network IDS, intrusion detection systems, which is be mounted into the walls. So likewise, if you have been exactly identify number of devices, then you can decide the network. That is the main key component, key point, which you really need to understand here. So the important thing here is you need to utilize the private IPs. That's the most important thing. And then again, the private IPs basically basically uh, basically so basically what we can do here is once you understand the number of devices which we really require to deal with it, of course what we can do is we can then select network. So let's uh, look at how we will be going to decide this networking concepts. So as I told you, when you are going to deal with this network design, so the very first thing is you need to you need to understand the number of devices. Uh, in my experience, when we are dealing with this CCTV cameras and the access controls deployment, most probably the number of devices which will not exceed 100. I'm not quite sure whether you have deal with the more than that environment, but the maximum number of I have deal with is that is less than 100 devices actually, like not even 100, like it's less than 50 even. So the camera and then the access control, when you connect together all the things, it's less than the like 50 to in between the 50 to 20. That is the maximum number of devices that I have gone through for the installations. But of course, in your case, when you are dealing with the buildings, obviously you might come across with the devices, number of devices, which is more than the 50, but I'm not quite sure whether it is go beyond the 100 even. But let's just say, no worries, just like whether you have 1,000 devices, still that we can scalable these network without any concerns, without any issues. The only concern is the distance that you are going to deal with it, with the devices and the termination device. That's the only thing that you need to too much worry about when you are dealing with. But anyway, when you are going to deal with this IPv4 address selections, just keep in mind the main technological aspects here is the 32-bit address space having two portions. Two portions. One is uh, basically the network portion. The other one is the host portion. Let me explain this one in this way. This particular theory. Let's just think about like if we want to talk like this particular network portion, or rather we call it as a subnet, which is defining your boundaries. Let's just simply think that if we conduct this particular webinar in a physical manner, so basically we will be having direct contact in between you and me, where we can directly talk to each other. Let's say there is another webinar session in the next room. If anyone wants to talk to the persons in that particular webinar room, so obviously what you need to do is, in order to talk to him, you need to go passing the door and then go into the next door. So you have to pass the doors to address this particular person. So that's where we create the boundaries. If that by looking at the subnet or the network portion, the devices, because they are not human beings, so obviously that is this is just a hypothetical scenario that we are considering. Since these network devices, in order to understand their boundaries, we need to create a mathematical boundary there. That is where we consider as a subnet or the network portion, where we tell if you want to talk to any, let's say two devices are there, A, B, and C. If you want to talk to the B device, if this is your subnet or the network portions, that means you are in the same environment. You can directly talk to each other. But the C is we are setting with the different network portion. That is, we are creating a different boundary set. Now, if the A device wants to talk to the C device, they need to go to the door and pass the door to access the C device. That is where we call it as a gateways. So when you are dealing with this network technology, when you configuring an adapter into those things, we will be putting three things important. One is the IP address in the configuration parameters. The second one is the subnet mask. The third one is the gateway. IP address, of course, we will be putting for the communications. Subnet mask, we are going to say, this is your boundary. If you want to talk to anyone, you can talk to any people which is directly within your boundary. If you want to talk to anyone else, this is your gateway, the door. The door is open. You just go out from the door and talk to any other person. So these are the three parameters which we are going to configure in the network card or NIC when you are dealing with the network configurations. So this IP address will contain two portions. One is the host, the network portion. The other one is the host portion. The network portion, or rather in the other terminologies, we call it as a subnet mask, which will define exactly your boundaries. The host portion is the IP address which we are going to install into or put it into the device. So that is the unique address that we are going to put. So when we are going to deal with this 32-bit IP address, 32-bit IP address space, So basically, that is the subnet mask. So when you are going to deal with this, this is exactly what you need to understand. So you can see that in here, in the network portion, you have a 192.168.10. This is what you call it as a network portion. So this particular part will be break it in here. The rest of the 8 bit will be considered as a host portion. So if you look at here, so 8 bit, 8 bit, 8 bit, that is the 24 bits will be there. The rest of the 8 bits will be considered to the host portion. So that is basically the host IP. We are assigning to the network. We are assigning to the host mapping in that particular network. So that's what you really need to understand here. So this is what we call it as subnet mask. So you don't want to really worry about it. Just put the /24 there. So the /24 will be basically the /24 basically will be the network portion here, because we are going to use 8, 8, 8, 8. So the /24 bits will be allocated to the network. So this is where, so any device in here, so just understand, if you see 192.168.10, any device which are going with this network will be in the same. If you use the 192.168.11, it is in a different network. So that's how we will be breaking this particular portion, network portion. Here the host portions containing 8 bits, 8 bit basically. That 8 bits means if you look at the number of hosts that you can create is 2 to the power 8. It means basically 256 hosts. Actually, you need to deduct 2 from this 256. That is the standard. And maximum number of hosts that you can assign with this one is 254. So just imagine when you are going to deal with this environment. So if your host portions are having 8 zeros or 8 ones, 8 bits, that means you can create the 256 devices, ultimately 254 devices. So this particular concept, we call it as a classful environment, classful. When you are dealing with this networking, so we do have two different ways. Like when you are designing the network, to decide the number of hosts and to design the IP address, to design the network, you have two different ways to do that. One is classful network, the other one is classless network, where you definitely don't want to worry about the classless network, because the classless network we will be really using specifically when you are dealing with the IPv4 public addresses. Actually, the reason why we are using here, let's just imagine if you have only 100 IPs, 100 devices. So we are going to use the /24 network. That means this 8, 8 and 8 will be network portion. This 8 will be the host portion. So there are 250 devices, 54 devices can be utilized, but actually we are using only 100 devices. So there are 154 device IP addresses are waste where we cannot use it. Therefore, that's why they have introduced, to minimize those IP wastage, they have introduced the classless IP address concepts, where really we don't want to worry about it. That is 100% guaranteed, because since we are not dealing with the public IPs. See, these are the private IPs that anyone can utilize it and anyone can use it. So therefore, nothing to worry. So it's just a simple thing. So we will be dealing with the classful IP subnetting. Classful IP subnetting. So the classful IP subnetting, just imagine here. So we have three different classes. Mainly we are dealing with these three classes. Class D and the class E we will be not going to utilize because these are specific purposes. These classes are designed for the specific purposes, especially these are used in the research lab environment. Therefore, we will be definitely not going to deal with the class B and the class E environment. But in our case, most probably we are dealing the class C, where the first 24 bit will allocate for the network. The last 8 bit will be allocated for the host. In that case, we can create 256 IP addresses for the devices, and ultimately we can use only 254 devices IP addresses. The class B it is again 192, like the first 16 bit will be allocated for the network. The last 16 bit will be allocated for the host. You just imagine number of hosts that we can create for each network. 2 to the power 16, that is 65,536. Basically again minus 2, we can use the devices for the 65,534. Just keep in mind, like you can just think, obviously guaranteed that one, we don't have a, even the largest building, the building in Sri Lanka, that doesn't have definitely 65,000 devices, ELV devices. So you don't want to, that's why I told you, like you don't really want to even worry about the class B network. What we can survive here is, most probably we can be able to survive with the class C network. But if you are reaching more than 254 devices, more than two, at least if you have 255 devices to mount, of course, you need to survive with the class B IP address state. There, you need to use 192.168.192.168 dot, like you can say 0.0/16 network. So we basically write it down in that way, /16 network. So we are assigning in that manner. So 24 is the most probably the most common mechanisms. Mostly you are using this one because we can survive with the 254 devices. And here you can see that they have been assigned the IP addresses as well. Keep in mind, there are no such like that. You don't want to too much worry about. Even when you are dealing with this IP address scheme, you can use 192.168.0.0/16. That is the subnet mask. This /16, you can use it. But here they say class C IP addresses which are starting from 192.0.00 to 223.255.255.255. Basically, the entire IP address is in a decimal way. We can start with 0.0.0 and that will be goes until up to the 255.255.255.255. This is the last IP address that we can have. This is the first IP address that we can have. In between these things, we have 4 billion IP addresses roughly. But in our case, in this classful network, they have been like separated the IP addresses as well. But for your record, it is not like that. You can use even 192.168 IP addresses in the class B network as well, because it's just a matter of separating your network, nothing else, because these are just the numbers. So the class B, class A, class C, there are no boundaries with IP addresses. You can define with the IP address which you really require. Like even here, 10 range IP will be fallen under the class A, 10.10. Whatever the IP address. Because here 0.0.0 to 1727.255.255.255 will be laid under the class A IP set subnet. But actually, sometimes in our cases, we will be using 10 range IP addresses even in the class C network as well. We can say 10.100.100.0/24. So the net mask is set to the network portion is set to the /24, right? So still the 10 range IP address is in theoretically, it is a class A IP address, but we have used in the class C. That's what you really need to understand. There are no such requirement that you have to deal with the exactly what the theory says. You can shuffle, you can utilize, you can use it, it's up to you to decide, because the reason is these are the private IP addresses. You can play with your own wish. So you don't want to worry about it. Since these are private IPs, these are not public IPs. So private in the sense private. We can pick a house in layman environment. We can put any name. So it's just a private name. It's not the postal officially given email, so postal officially given address, not the government given address. That so of course guaranteed you can decide. But theory says like this. Theory says like this. But still, you have a you have a freedom to select what you really want. But in our cases, in most of the cases, the reason why I'm telling, in most of the cases, we can survive with the 192 IP addresses. And now, in that case, you need to decide whether you are going with the IP version 4 or whether you are going with the IP version 4 with the 192.168 address, or 192.168, 172.24 address, 172.25, 172.16, 172.17, 172.18, 10 range anything, 10 range anyone, 10.1 dot, 10.100, 10.2 dot. So entire 10 range will be considered as a private. Entire 192.168 range will be considered as a private. The some portions of the 172 range will be considered as a private, as I told you, 172.25, 172.26, 172.16, 172.17, 172.18 IP addresses. So that's how we can play with. In our case, we can definitely select the based on the number of devices. Of course, you might not go beyond the /24 network because it's not really required. It's not really required. So that is what you really need to understand here. So basically, in summary, as I told you, when you want to select the network, you need to first select when you want to select the network, you need to first decide the number of devices which you really require. Based on the devices and deliver right subnets, so you can select either ones. So one of that subnet, you can IP range, you can select what you really want to deal with. So it's not a big deal. It's a very simple thing, and you can select it. So this is actually one of the important thing that you really need to understand here when you are going to deal with this IP addressing schemes. IP addressing schemes. So why we really using this IP addressing? Why we cannot go with the analog systems? Because of course the previously, uh, if you look at the most of the like nowadays, if you look at most of the access control systems, those are definitely comes with the network enabled environment. That means they do have a network interface card. But if you look at the CCTV cameras, because in most of the cases when we are implementing the ELV system, most of the time, like 90% of the time, we will be dealing with the CCTV cameras or access control systems. That is the major components we are using. But of course, apart from that, there might be intrusion detection systems which we will be mounted to the walls, and that is also right now we are getting with the devices which is enabled with the network interface card. So that means they also supporting the IP based system. And apart from that, like let's say for example, door communication units. Door communication units also right now we are getting with the network interface card enabled environment. Most of the door communication. So, but only thing here is the when you're dealing with the CCTV, we are getting with the board. We have the analog systems where we will be Home 3C 2V cables, Home 3C 2V cables, that is a coaxial cable to terminate your communications, CCTV communications with your DVR or rather we call it as NVR. Right now, we name it as a, previous it was named as a DVR when you are dealing with the the fully analog systems. But now, since we are dealing with IP-based system, we call it as a NVR, network video recorder. DVR is a digital video recorder. So if you look at the analog systems, whenever you want to deal with this implementations or installations, the very first thing is we need to get the quality coaxial cables. I'll tell you my experience as well. We have some installations where we have used actually the a Chinese cable, where the coaxial cable having very poor quality on that. So that copper cables are less copper cables in that particular COM3C2V cable, coaxial cable. But this Chinese cable is very cheap. Due to the cost factor, we have to we have to go with that the Chinese cable. But actually, like if you look at the KML and Kalani cable, they actually KCL are providing a very solid, very quality coaxial cable to the market, but unfortunately those are very, like, prices are very high. So because of that, we have been gone with the Chinese market cable sets, and ultimately it has been drastically down the quality of the images, though we have been used the 2 megapixel cameras. That is the issue. So analog systems, we are having a lot of issues with the qualities depend on the cables that you are using. Though you have been purchased a very high quality, high resolution cameras, even that is analog system also having very high quality, high resolution cameras. But though you have purchased it, still you are having a lot of issues if you have not purchased the correct cables. If you have gone with the cheap cable, of course you cannot survive the energy. You are having a lot of issues with the insulation. The first thing. The second thing is that is the image resolutions and the quality. The second thing is the terminations. Every time you need to do the termination. And the most important thing here is if you have been mounted, those devices which are actually exposed to the outside, so those jacks will be like damaged, and then corrosions. There are a lot of issues. The maintenance is there. Every 1 year, obviously that might be good for the companies, the service providing companies, but for the client it is not actually good thing. So the corrosions and then the damages, lot of things are there. So therefore that's the maintenance cost is involved, and the insulation is not easy, the termination part, because we need to put a lot of efforts to the crimping those things, and then mount into the jacks, and then properly trim those cable and mount it. So that is the case. But when it comes to the IP addresses, IP cables, guaranteed that one, it's very much easy to install. Very, very easy to install. The first thing is that because it's just we will be using the RJ45 connectors. It's just a simple thing to the terminator. So we are going to use the Cat5. I'll tell you what kind of cables that we really need to use. We really need to use it. Cat5, Cat6 cables are there. So we call it as those are Cat cables. So the Cat network cable. So those Cat5 or the 6 cables can be utilized. So once it is used, it is used. So there are no maintenance unless if you are migrating. If you are, let's say your office is moving from one building to another, then of course you need to remove all those security that you have implemented and install into the other building. So on that cases, obviously you have to do a lot of work, but unless you don't want to even touch those things, if that device is gone, if there are failures in the device, other than that, there are no maintenance. That is quite sure, because it's one time installations, then done. And the most important thing here is when you're dealing with the analog system, when you are going to deal with analog system, of course, you might need to deal with the uh, basically uh, laying out the power cables as well. Power cables as well. So in that case, of course, what you really need to understand here is there are two cables that we are laying out. One is the coaxial cable, the other one is the power cable. When you are dealing with the IP addresses, there is a concept called power over Ethernet. We can send the power over our Ethernet cable as well. That means Cat6 or Cat5e cables. That is quite sure. So the power over Ethernet is possible. So only one cable that we are going to lay out, entire the power and the data will transmit on the same cable. So that's the thing. The third one is the security. This is most important thing. When you are dealing with this coaxial cable and the analog system, your data is not encrypted. Whatever the data which you are sending, if someone tapped into your this environment, they can grab your data. Encryption in the sense, what you really mean by the encryption is, we are before we are sending the data to the recording devices, we will be converting into the unreadable format, where even someone tapped in the middle of your cable, though they grab the data, they cannot read it. It's a waste because it's in a different format. The 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 recording device can only be able to decrypt or convert it to the readable format. That is what we call it as a decrypt. So the IP based systems have been automatically enabled the encryptions. While they are sending the data, those data are encrypted. So no one can grab it. Even they grab it, no one can read it. So that is the security that they have enhanced. Then next thing is the compatibility and the multifunction. You can integrate, let's just say for example, your CCTV systems even can be integrated with your access control systems. That possibility is there. Then you can look at the access control biometrics part and as well as the video, whether he's really put it that one. Put it that one. Because there are cases, we have been seeing a lot of cases in Sri Lankan context as well. We can tamper the fingerprintings. That is possible. So there are cases that we have been like red-handed court cases are there. We can tamper the fingerprinting. So, but when you have been integrated that fingerprinting machines or the access control machines with the CCTV cameras also, you can ensure that the exact person have been put the fingerprint there. So the compatibility and multifunctionality is enabled with IP addressing, these IP-based systems. And the most important thing is you can access these devices from anywhere, but this is the risk that you need to understand. Whenever you exposing your ELV systems to the internet, keep in mind there are several sites which actually list down your environment. Guaranteed. If you put your default username and the password, like most of the devices we are getting admin to access the devices. If you put the default without changing it, the hackers can access your environment. That is quite true. Guaranteed. I'm not going to discuss that one in this particular environment, but just keep in mind there are set of websites which are listing down all the network connected devices. It can be the router, it can be a CCTV camera, it can be a network NVR, it can be anything, even it can be your laptop as well. If you have a permanent public IP address, fortunately we don't get that one. But if you do have a permanent public IP address, of course your device also will be listed in one of those sites. There is a site called, you can even look at that one, Sodan HQ, SOHADAN HQ. So that is one of the major sites. Even the hackers are looking at, even also we also looking at. So both people are looking at those sites. Some even we have seen some Sri Lankan CCTV camera systems has been exposed to the internet, and they are using the admin access. So you can access those their devices very much easy. So keep in mind that one. when you exposing any kind of your endpoint devices to the internet, please remember to reset your passwords. Put one of your password, not the default vendor passwords. Then again, the next thing is the convenient data storage. You can store your data at any locations. Cloud, basically what we call it as a cloud. In our environment, you don't really want to worry about the cloud. What we really mention the cloud here is the any kind of services which are provided by the third parties. Say for example, Google Drive. Google Drive is a cloud service where you can integrate with your device recorders or any other devices to store the data. Or you can use the shared drives like OneDrive, which is provided by the Microsoft. Or even you can use Apple storages. So whatever you really require, you can store those things in the storages, then cloud storage. But that is obviously it's a bit of cost one. So you need to make payment in the dollars. So that is the only concerns that we are having, but you can consider that one. And then the next thing is the scalability. Let's say in first phase, you are been dealing with the first phase you have been dealing with 100 devices. The second stage you are asked to deal with another 100 devices. Nothing to worry. It's just a matter of adding another device, the PoE device. We'll discuss that one in the next slide. Just a matter of adding the PoE device. So the PoE device will basically add it and then plug all the network devices or the ELV system into that one. So it's just a simply scalable. Simply scalable. We can do it very easily rather than dealing with the analog systems. And as I told you, less wiring, definitely guaranteed that one. You need to deal with the less wiring. Power, you don't want to lay out layering powers, and just need to use the cable Cat6 or the Cat5 cables. That's it. So this is actually, as I told you, like every technology has a disadvantages as well as advantages. But when you look at if your advantages over the disadvantages with the other technologies, definitely you need to adapt. Here also the same thing. If you compare the analog systems and the IP-based systems, the advantages is more than the disadvantages. So therefore, we are adapting this one. The higher cost, definitely cost-wise, is we need to spend more than the analog systems. That is quite guaranteed. And then the demand on the bandwidth. This is one of the important things that we need to remember when we are dealing with the uh, the IP-based systems. So we have to deal with the bandwidth. Therefore, the recommended and the most effective ways when you are dealing with this IP-based ELV system, it is better to layer in separate Cat6, Cat5 cable with the separate devices for your environment. That is the recommended way. That is how we are using actually. So when we are dealing with the this environment, so almost for the data communication, because we will be using the same set of devices, same set of physical environment for the data communications as well for the PCs. And when you layering the cables, recommended to separate those cable layers. For the PCs, you need to separately layer the cables. For the ELV system, you need to separately layer the cable. Of course, in that case, you can safely disregard this particular point, disadvantage, demand on the band, because then of course we have a separate uh, device set and the physical environment. Because here what we are talking is not just a kilobyte of size data. When we are sending the videos, pictures, or any in the CCTV environment, of course it's a megabyte size of data. It's consuming your total bandwidth. So therefore, it is definitely recommended to have a separate networks, separate cable layering for the your ELV system. Uh, and when you are dealing with this IP-based ELV system, of course, you really require considerable amount of IT knowledge. That is definitely there, but not much actually. So everyone can understand these concepts. These are not rocket science anyway. So everyone can understand with the simple layman ways. So it's not much required, but only few things that you need to know. We have almost cover like 6 to 70% in here what you really need to understand in the IP address IP based systems. But there are another 30% also that you need to consider when you are dealing with this dealing with the ELV system. So the next thing is when you are going forward. So if someone asks what are the devices which we need to select, of course, all the ELV based systems today, if you buy anything out in the market, as I told you, any kind of access control systems, any kind of CCTV systems, any kind of uh, intrusion detection systems, anything like that. Of course, they are right now integrated with the network interface card. Even door video systems, they are integrated with the network interface card. By default, in the design itself, they are dealing with the IP-based environment. The next thing is, the, and when you purchasing the let's say for example cameras also. So the camera you can purchase like the let's say this is what you need to understand. Normally, if you look at the camera, if you purchase the camera which is a high quality camera in the analog system, like it is more than 20,000 25,000, you can get the same quality with the 15,000 IP based camera as well. So just keep in mind that one. So that is there, like the quality will be bit of higher than the analog cameras. So basically in theoretical environment, what they says is the image quality is 20 times better than the analog cameras, but that is the theoretical what they say. But you need to understand at least 10 times is better, not the theoretical. We cannot take the exact theoretical aspects, but at least 10 times is better than the analog cameras. So the next important thing is selecting the cables. Nowadays, we definitely recommend you to go with the Cat6 cables. Don't go with the Cat5e as well. The reason is this. We have a different type of UDP categories. Cat1, Cat2, Cat3, Cat4. These are obsolete. Now we don't have anything in the market. Cat5 even this is obsolete. So what we having right now is cables with the Cat5e onwards. In Sri Lankan market, you can purchase the Cat5e cables as well as the Cat6 cables. I'm not quite sure this Cat6A cable and the 7 cable is available in the market at the moment. But these two cables, Cat5e and the Cat6 cable, will be available in the market. The difference between 6 and the 5e is uh, the Cat5e cable, you can go ahead with the 1 Gbps speed. That means when you sending the data, they will be the Cat5e cable is capable of sending 1 gigabit per second. 1 gigabit per second. If you go for a Cat6, they are capable of sending the data 10 gigabits per second. 10 gigabits. Actually, when you purchase the other devices, like when you need to purchase several other devices as well. We are going to discuss that one also. When you purchasing the other devices, that device basically supporting maximum up to the 1 Gbps. We don't have devices which are supporting to the 10 Gbps at the moment, especially in Sri Lankan context. There are devices, but in Sri Lankan context, when it comes to the ELV systems, our devices, other devices, maximum supporting the 1 Gbps. Therefore, you can survive with the Cat5e cable as well, but the Cat6 also possible. We are recommending to use the Cat6 cables. That is quite good, and if you compare with the Cat5, but the matter is it is the data rate that we can see. The maximum length obviously 100 meters. If your devices, if your ELV equipments, end devices having a distance more than 100 meters, of course you need the repeaters. Repeated in the sense you have to have another switch in between the termination devices, and first go to that device, and then from that device you have terminated to the termination device, or the called NVR, network video recorder. So we cannot directly plug the end device with the NVR or any other PoE devices, especially when you are dealing with the cameras, because the most important thing is the cameras. When you are dealing with the cameras, if you are NVR and the camera having more than 100 meters, guaranteed that your images will be lost. You cannot get the exact images there. So therefore, when you go for a selections on the cables, if the Cat5 is available, you can purchase it, but recommended to purchase the Cat6 cables as well, because I don't think much price differences in between Cat5e and the Cat6. Because the reason why I'm telling you, if you think of upgrading the devices at some point of time, of course, it is not practical to provide the new cable layers, because lay out the cables again and again. Once you lay out the cables, so that will remain forever in your environment premises. That's why just go with the higher one, because since there are no price differences, just go with the higher one and put it there. And when you have a if your client is requesting to upgrade your environment and provided the 10 Gbps network, of course you can easily upgrade. It's just a matter of replacing the devices only, because cable will remain as it is. So that's what you really need to understand when you are dealing with this one. That's why I'm telling that you have to go with the Cat6 cables. Cat6 cables. So the next thing is you need to select the in your other ELV system, you have to select definitely power over internet enable switches. There are different type of switches which we are talking. In technological terminologies, we call it as a layer 2 switches and the layer 3 switches. In our case, we don't want to think about layer 3 switches. Layer 3 switches will be higher switches, will do more functionalities in the network environment. They are supposed to do the routing. In our case, we don't want to do the routing. They has not to be act as a path teller. Basically, layer 3 switches are the path tellers. If some data packet wants to go, they will tell how to go. We don't want to do that one, because we know that's it's a simple network. We know the devices are connected within our environment, so we don't want to tell where to go. We exactly know. So like a village, we know our neighborhoods. We don't want to tell someone to go there and this is your house, this is others house. We don't want to tell. So basically, the power over Ethernet switches you need to purchase layer 2 switches. Layer 2 switches. Keep in mind that one, layer 2 switches. No layer 3, because layer 3 is a high configurable switches where we don't really require. Power over Ethernet should be enabled in the switches, and it should be a layer 2 switch. Just the switch. They do the connectivity only. They connect the devices each other. When it comes to the CCTV, it is better to get the network video recorder, which is having the power over Ethernet and with the switch ports. Now we have a two different NVR. One is the NVR is capable of power over Ethernet, but the concern here is they don't have enough network port to plug all the CCTVs. In that case, what we are going to do is we will be going to plug the power over Ethernet switch into the NVR, and all the cameras will be plugged to the switches, not to the NVR. So there is a lag in between the switch and the NVR. Like if the main cable plug in between the connected cable in between the power over Ethernet switch and the NVR is bent down, so the recording will not come to the NVR. Therefore, the recommended, when you are dealing with the CCTV, the recommended, try to purchase NVR with the power over Ethernet. Let's say if you have a 20 CCTVs, try to purchase with the 24 ports NVR. So those NVRs available. Both type of NVR are available in Sri Lankan context specifically. So you can purchase. In our case, but it's like this. But if you do have a more than 20, like it's say, let's say just 50 plus cameras, of course, the better way is going with the power over Ethernet switch and separate NVR with the single network adapters. But if you have less cameras like 10, 15, purchase NVR with the network ports availability. So that is the best way. So this is what you need to really understand here. Definitely, you need to purchase the switches, which is capacity, having the capacity of power over Ethernet, PoE switches. Switches should be the layer 2 switches. Don't go for a layer 3. Nothing to worry about. We don't too much worry about the layer 2, 3 switches. And then again, the NVR. If you have less cameras, 20 or less cameras, purchase the NVR where we can plug all the 20 cameras directly into the NVR, not to the power over Ethernet switch. But if you have more cameras, like 50, 70 cameras, practical ways, don't purchase the power over Ethernet with the which we can directly plug into the all the cameras into the NVR, because that type of capable NVR is not available in Sri Lankan context. Like most probably it will not go beyond the 48 ports in the NVR environment. So purchase a NVR where you can just 2 network port is required. You can directly plug the power over Ethernet switch to the NVR. That's it. All the cameras will be plugged to the power over Ethernet switch. So that's a simple thing. So these are the devices which you require. So there are other devices also, like when you purchase the let's say for example, door communication unit. Of course, you need to purchase the door communication, which is having the support for the power over Ethernet as well as the network connectivity. IDS, IPS also, when you are purchasing the wall related intrusion detection systems, purchase those things with the network ports. Right now, as I told you, all these devices are coming with the network port in the device engine. So this is one of the important thing when you are dealing with this is the crimping actually. When you are going to crimping the tool, crimping this cable into the RJ45 cable, there are two standards that we are dealing with. T560A. T560A color code will be goes like this: green, white, green, orange, white, blue, blue, white, orange, brown, white, brown. Actually, the way that we have achieved this one is we are sending power as well as data over the same cable. It's actually like this. In here, we will be using, this is the crimping way. First, for the first RJ45, we have to use the white, green, green, white, orange, blue, white, blue, orange, white, brown, brown. Actually, we are using pin number 1, pin number 2, pin number 3, and pin number 6 for the data transmission. This is common for all the network environment. Wherever you use the RJ45 with the T568A cable environment, Cat6 environment, of course, what you really need to do is we are using only 1, 2, 4, and 6. The rest of the things like 1, 2, 3, and 6. 4, 5, 7, and 8 will be definitely used to transfer the power. That's how we are using. As I told you, there is another standard, that is what we call it as a 568B. 568B. 568B, which is again having white, orange, orange. You can see the difference. First, previously it was have the green, white, green. Now white, orange, orange, white, green, blue, white, blue, green, white, brown, brown. So in that case also nothing to worry. 1, 2, 3, and the 6. These are the cables which we use to transmit the data. 4, 5, 7, and 8 we use to transfer the power. That's how we will be sending power and the data in the same cables. So that is the way. Normally, when you are dealing with this environment, you should remember to use either one of these cabling standard, either the T568A or 568B. Most of the time we are using this 568B when we are dealing with the crimping. It's not like that. It is not a standard or it is not recommendations. You can decide, but when you use that one, you had to use in across your building. You should use the same technology, same standard. So that's what you really need to remember in here. Right. So the common issues with the IP technologies is main thing, as I told you in the beginning, conflict. We mistakenly IP address might be conflicted. So the easiest tool is just plug your computer into that particular network, into that switch, and ping to that device address when you set it. If there is a conflict, you cannot be able to ping. And then remove that particular cable and you try to ping it. If there is another device with the same IP address, you will be able to ping because that conflicted device you have been removed. So then you need to change the IP address in that environment. So the ping is one of the important tool when we will be heavily using for the troubleshooting, which is related to the IP technologies. Ping tool, IP address conflicts. The next thing is the next common issue that we are getting here is we will be not crimping the cable in a proper way. That's why I told you, like if you have used two different technologies, it's a conflict of crimping. So you have to use one standard and you have to stay with that standard and properly crimp it. If there are any issues in the crimping and even data losses, because there might be damages while you are layering the cable. So when you are digging the ducts and then like crimping those things and closing those ducts, so there might be damages to the cables. So then of course we can use the cable tester. The cable tester will ensure that uh, you are having the correct connectivity. One end has to be plugged to this particular device, the other end has to be plugged to this particular device. So then once you switch on this particular with the BIS button, so they will exactly go with 1 1 2 2 3 3 4 4. And if there are any missing in the communications, that means the cable is damaged or you have not properly crimped it. So you need to crimp again and then check it. If you getting the same thing, so there is a damage in the cable as well. So that you have to check it by getting out all those ducts. The next common issue is the RJ45 adapters is not properly connected. So if it is not properly connected, you will be seeing here the LED status ports. In each and every switches, you will be definitely seeing, even in the devices also, you are going to see two lights. One is the amber color lights, one is the green light. Whenever you have properly connected, this green line has to be on, blink and on, blink and on. If it is not blink and on, that means there is a loose connection in between your device and the end device, the power over Ethernet switch and the end device. So you might need to check and properly connect the RJ45 as well to the end devices. These are the basically most common issues which we are getting with the IP technologies. Not much actually, you can see it's very simple. The most of the time what you are getting is the cable damages actually, and they're not properly crimped due to the different issues. So that is the main issue, but you might see some issues with the crimping as well. Sorry, the conflict as well. The next thing is the IP address configurations. Like when you go for IP address configurations, you might come across with the issues. So like you might put the wrong subnet, you might put the wrong gateway, you might put the wrong IP addresses, like configuration issues, like you might type, there might be typos. So in that case, most of the time what we will be doing is we can again use the same tool, ping tool. Ping tool is only available with your Windows environment. So just take a CMD command line and type the ping and then IP address and then try to ping it. If it is success, you will be receiving this kind of message. like reply from this one, reply from this one. If it is not success, you are not going to get anything. You will be seeing the packet losses. That's it. So otherwise, you can straight away go to the that particular network interface and check one by one again. We have correctly put the IP addresses and the subnet, because there are 3 parameters you need to understand: IP address, subnet, and the gateway. If you have put those three things in correct manner only, you will be getting the proper IP address configurations there. So these are the very common issues when you are dealing with IP technologies. It's not only for the ELV systems, but it is always for all the IP technology devices, even network environment. So the last part that we will be going to discuss here is what you need to do and what you not need to do in here while you are dealing with the ELV systems. The very first thing, there is a way that we call it as, even in your home environment, your router will be assigning the IP address to the computers. That is what we call it as a dynamic host configuration protocol, means DHCP. Do not use the DHCP to assign the IP address. The reason is, when you assign the DHCP, when you use the DHCP server to assign the IP address, timely manner, the IP addresses will get changed. It should not happen. When you configure the IP address for one camera, it has to be static. That has not to be changed, because we are configuring the camera to the NVR devices by using that IP address. If it is get changed, so that device will not going to properly connect to the NVR. So don't use the DHCP, because the DHCP, in the sense, IP address will change timely manner on the devices. That is one thing. Then see here, do not exceed the camera to NVR or switch durations more than 290 feet. That means basically 100 meters. So that is one of the important thing that you have to remember. And then do not use the PoE switches if possible. Instead, use PoE enable NVR. As I told you, if it is possible, use always PoE enable NVR with the necessary ports. But if there are any requirement like more than 50 devices, of course, there are no ways to do it instead of using the PoE switch, right? And then again, the important thing, reduce the wall outlets as much as possible to your end devices. Let's say, for example, to the camera environment, to the access control fingerprint device, to the door communication unit. So don't use the wall outlets, just straight away terminate into the device. That is the best one. And then again, the do's that you need to do here is, you have to use either standard, either you have to use T568A or T568B. That has to be consistent across your building environment. Don't mix up those standard, just use one. That is fine. Just use one. And always remember to reset the default password of the devices. That is must be definitely has to be done by yourself, because otherwise hackers will control your devices without your knowledge. Guaranteed that one. And then the Bain radius, of course, when you are dealing with the Cat5e and the Cat6 cables, so don't bend it the radius less than 1 inch. So that is quite sure. Otherwise, it again leads to your data losses. You will be not getting the proper images, proper data into the end devices. Just keep in mind that one. So reduce the bendings in the cable layerings. So always try to do that one. So these are actually do's and don'ts when you are dealing with the this particular IP based ELV systems. So we have gone through a set of discussions with the IP based environment. So if you do have any questions, the floor is open you to ask questions.
Thank you very much, Suran, for the valuable session. As you clearly stated several times, this in the industry, we have a lot of issues. I mean, the biggest issue is many people are a little bit scared to go ahead with IP-based systems due to various concerns. And today, within your session, I think we got to know the certain complexities, and you cleared most of them. And I believe from for the engineers who are frequently dealing with ELV system, it was a wonderful input. So thank you very much, Engineer Suran, again for enlightening us on these particular areas, especially IP technology, as you emphasized several times. Definitely be the future. Not only for even ELV sector, many sectors will be using these IP-based technologies in the future. So there are a lot of questions which directly came to me. Actually, I would like to get your opinion on these things. At the same time, if anybody from the audience needs to get cleared anything, just raise your hand through the icon, and definitely we will unmute your microphone so that you can post your question. In the meantime, you can keep on writing them. We have a wonderful resource person today available. So any doubt, any issues that you have had so far could be realized, cleared today. Many of you definitely be using IP devices, starting from your desktop computer, starting from your laptop computer, your mobile phone. If it is connected for your WhatsApp or Viber connection, definitely it is an IP device. So when you are using them, you would have encountered so many issues. So today would be the ideal time for you to get them clear. So there's a question appearing here. First, I will prioritize the question appeared in the chat box. What is your opinion on Wi-Fi CCTV system? Actually, yeah, in general, what do you think about having your CCTV camera connected through Wi-Fi?
Yes, that is actually good questions. I must say this is so in our environment when we are dealing with the Wi-Fi cameras, so we do have a lot of interferences like walls, barriers. So though that the camera, let's say when you're purchasing the camera from the market, so sometimes they might say the wireless strength will be goes for a 5 meters, 6 meters, 10 meters. But actually, when you install the cameras in that particular building environment, due to these interferences, the the strength of this wireless, because we have to deal with the wireless waves. So the strength of that waves will be not go beyond the 2 meters. So of course, you will be again receiving the data losses, and as well as you are not getting the clear images. So in the CCTV environment, Wi-Fi type of CCTV systems is pretty much better for a closed environment. Let's say, for example, if you have rooms and then again other rooms, and if you have like 2 to 3 meters distance in between your recording device, NVR device, and as well as the cameras, for like a small closed environment, the Wi-Fi cameras are pretty much better. But when it comes to the building environment, the Wi-Fi cameras are not recommended because of the interferences. And even once the building is established, so the people will create different boundaries there as well, like different obstacles. So that will again impact. So so we have to be watch out on those things as well. So when it comes to the building environment and that kind of environment, the CCTV, Wi-Fi CCTV is not recommended, but still that is recommended for the closed environment.
Right. Thank you, Suran. I hope the particular engineer would have got the sufficient answer there. And Mr. Suran, we have seen when it's come to the early stage of network, I have seen the data network used for the administration work, like all the maybe the data network used for HR department and administration department, also used for connecting CCTV and rest of the devices as well. I have seen this kind of installation in, actually, I saw that few years back, almost in 10 years back. But nowadays, it is recommended to have a separate ELV network, data network for ELV applications only. So anything to be added, is that a good practice, or what is your opinion on that?
It's not basically the good practice. What we are recommending right now, because this having two things, like when it comes to this CCTV network or the any other ELV systems, the security, what we saying here is you need to isolate the network. So the data network which we are sending definitely has to be isolated with the ELV system, because that data network might carry very much sensitive data. Like even if you look at the HR functionalities, of course, that is they are having the payroll systems, they are having the leave attendance systems. So those are actually very much critical things, and it contains sensitive data, especially the payroll system. So in that case, if you mixed up, because the reason why I'm telling here is when we are dealing with this ELV system, sometimes these are the most vulnerable system in a company, because we might not really care about the security even here. So in that case, we put, if you mixed up those things, if you send the same data set, same if you use the same network, same cables to send the ELV system data as well as the other data, of course it create a huge vulnerable network in your environment, and even the bandwidth, because what, as I told you, we are talking about the megabyte size of data when it comes to CCTV. So it's definitely consume the bandwidth where you are sending the other data as well. So therefore, definitely recommend to have a separate network, separate cable layering, and separate devices to ELV systems, and the data network has to be definitely send in the isolated environment.
Thank you, Suran. Actually, that's how it has to be.
Yeah.
If anybody who is involving with the ELV design, please make sure, if you are designing a network for building application, please make sure to have two networks. One is for all the administrative and financial activity. That's a separate network, which is called data network. Another network separately for the extra low voltage system. So that was highlighted. Thank you very much, Suran. And there's another question here. Please explain FOC cable. I think this is to be fiber optic cable connected to cameras where the distance is more than 100 meters. Fiber optic cable used for the distance more than 100 meters. Anything to be added there?
Yes, this is two things. One thing is we will be still not utilizing fiber optic cables for the cameras, because the cost, so the cable layering cost and the termination cost, because when you want to terminate the fiber optic cables to the network interface card, so we have to have a separate terminators. So therefore, what we will be not yet utilizing fiber optics cables for the camera and the installation of the camera. That is one thing. The second thing is, if there is if the technology is available there, like if we can able to deal with the fiber optic cables, and if we have the capacity to do that one, of course it is pretty much good technology where we don't want to too much worry about the distances, 100-meter distance, so that is no longer available. So that's of course we can go up to like any distance there, because fiber optics, obviously it's a very much good technology where we can send the data without wastages.
Thank you, Suran. And next thing that even I have seen in the industry is this over-engineered product selection. Sometimes due to the knowledge issues, especially this was highlighted in your presentation, also selecting switches for layer 2 and layer 3 applications. Sometimes, if you are blindly purchasing these switches from the suppliers in order to keep their sales volume increase, they would simply suggest you to go ahead with layer 3 switches, whereas your actual need would be layer 2 switches. So any, how, now if you're an engineer who doesn't have very good understanding on this area, what can we do to mitigate these things? Because end of the day, switcher suppliers, these all the hardware suppliers want to have a big money at the end of the day. So they try to sell something very expensive, but you want to keep your budget as low as possible. So any tips to avoid such scenarios?
Actually, it's like this. So when you want to deal with specifically the vendors, so you need to exactly identify your requirement. So basically, as I told you, in our case, definitely we don't want to go for a layer 3 switches, because these layer 3 switches will be utilized when we are dealing with the routing. So if you want to tell the path, that is the way that we are going to use. The layer 3 switches are not really required for the ELV system, because they are stayed in the our building environment. We'll be getting communicated within inside the building, so we don't want to worry about it. So when you go for a supplier, we might need to exactly tell what is our requirement and this is our budget. So that's the main thing that we have to reach out and with the suppliers, with the vendors, and then even though that they say, because they might say this is good one, this is not good one. So but still we have product specifications and we can search for the product specifications as well.
So budget could be a good input in a negotiation table in that case.
Yes,
Thank you.
yes.
Because I think that there's a drastic price difference between when it's come to a layer 2 switch and a layer 3 switches.
Yeah, exactly.
So yes, yeah. So that would be a good input to discuss when we are talking about the prices. And again, there's another question appearing. Some switches have dip switches to enable connect cable which are having more than 100-meter Cat6 cable. Will that work effectively? To be honest, I haven't seen a switch like this, but this gentleman says some switches have dip switches to enable connect cable which are having more distance than 100 meters.
Yeah.
So what is your opinion in that case?
Yeah, it's a kind like we can use that. Actually what we have mentioned here is the repeater here. So basically there are switches which actually we need to use the repeaters if we are go beyond the 100 meters. So exactly we can use that one. So there are no data losses, but we are doing is we repeating the signals and send it to the other end. That's it, simple thing.
So in that case, that particular switch has to be placed just after the 100 meters because
Yes.
yeah. So your first 100 meters you will have maybe your ordinary switch, and then in order to feed the second 100 meters you have to have this repeater in between. So it will have your dip switches or whatever configuration in order to enable that.
Yes.
So I think that question was also clear, and I have another concern. This is something that I have practically encountered. For the most of the commercial application, like commercial buildings, they provide this free Wi-Fi for the general areas, public areas. That Wi-Fi also connected to the ELE network. This is something I have noted in most of the extra low voltage application in Sri Lanka. That particular Wi-Fi network never be connected to the the main network of the building. It is definitely connected to the Wi-Fi network. Now, in that case, you have to directly connect the ISP line, the Internet Service Provider line connection with this ELE network. So what happens is, as you clearly mentioned, your CCTV cameras and everything now clearly exposed to the outer world. So that there is a huge security risk in that case. What should we do now? What is your input in a scenario like that, Mr. Soren?
So basically, the main thing is don't allow anyone to expose the ELV systems to the public Wi-Fi areas, because that will create another set of vulnerabilities apart from the internet connectivity. So definitely no one should allow to access those things through the public Wi-Fi's. So that is first thing. So then second thing is when we are dealing with this environment, so of course we cannot actually stop of exposing our devices or listing down the devices, those sites, like as I mentioned, Soda and HQ. So that is definitely they will be going to, whenever you expose to it, the internet, they can scan our devices and list it down. That is possible. So the best way is use the strong password to secure your devices. That is the exact best way that you can do. So no one can then definitely able to access it. Don't use the common password like adminnet123, abc123, you are the date of birth. Just use something strong.
So I think password plays a bigger role in that case in order to protect your all the devices from the external threats, external hacking. Because
Yes.
having your devices exposed to the whole internet world would be very dangerous, because this particular network will definitely have your access control system as well. So ELV network definitely will have your access control as well. So most of your data will be exposed. So please be careful in a scenario like that. Again, thank you very much, Suran. And there's another question appearing. A lot of questions are appearing.
Yeah.
May I know what need to be considered when migrating existing ELV system to new building? Can we use the same cable?
Yeah. Basically, that is not recommended, like, because when you are removing this cable, there might be damages, and then again the length issues. There are a lot of things. So just discard all the cables which are in the same new old building and use the new set of cables and layering from the beginning scratch. So that's the only thing that we need to do. Other than that, there are no set of steps to do the migration specifically to the ELV system. Just remove the other devices and mount it. That's it.
You can use all the active devices, all the
Yes.
physical devices can be taken, but the cable would not be recommended. The reason is, especially now when you are pulling the cable, even this number of twisting would be changed.
Yeah.
Because it's Cat 6 categories, you have higher number of twisting. So when you pull the cable, definitely this twisting will not be prevail as same. Definitely that will affect the data rate. So that's a good input there. And there's another question, do we need to have separate VPN for each different ELD system running on the same physical network? Yeah, I have some comments on this, but I would like to give opportunity for Engineer Suran to express his comment first.
Yeah.
Opinion on this, yeah.
Is it asking?
Yeah, I think what he needs is whether we should have separate VPN for each
VPN.
ELV system. Now, for an example, you have CCTV network and you have access control and you have BMS connected to this one. So is he asking whether it is recommended to have separate VPN for these each cases?
No, it's actually when it comes to the enterprise network, so we can survive with the one single VPN terminations. So, and we can access all these devices through the VPN. So we just need really one VPN communications. That's enough. So we don't want to have a separate VPN sessions, even when we are dealing with the especially financial institutions like banks. Just a simple VPN terminations, and from that they can access all the devices.
And next thing we have to highlight there is that your switches should also support VPN configuration. So if the switches are supporting, yeah, and
it's like this, Engineer Jagat, like switches, we cannot configure the VPNs in the switch level. So we should have a separate devices like firewalls to configure the VPN environment. And then from that points onwards only, we will be able to access it to the network.
This is VPN he's asking, no?
Yeah.
But yeah, I think this is not VLAN. Okay, yeah. Maybe it was, yeah, I think question has to be VLAN. It is not VPN.
Right. Okay.
I think, yeah. The question has, now that has been corrected. It is VLAN. Even I was under the impression of VLAN. That's what I said.
Okay, VLAN, of course, as you mentioned, so that obviously we have to have a VLAN capable switches, like layer 2 switches also having the capability. But in that case, if we are going with the VLAN environment, we might need to purchase the layer 3 switches, because there are routings that in between the different VLANs. And to answer the questions, that is the devices actually we really require. And to answer the questions, we can survive with the same VLAN. So if we are using the ELV systems, so we can put all the devices into the same VLAN and use it. So the rest of the other network has to be in a different VLANs. So that is possible.
I think the first question was VPN, virtual private network. That's a separate case. Actually, it's a totally different technology.
Yeah.
And the VLAN is something that you can create within the network. It is again, as engineer Suran said, that it is your choice. Sometimes if you have more devices, you can have a separate VLAN for your CCTV system, and something like that you can segregate. But if not, if the number is very less, you can have all the devices in same the network rather than making it unnecessarily complex. And next thing is, what is the maximum? There are a lot of questions related to the cable length. What is
Yeah.
the maximum length that we can connect NVR and PoE switch?
It's again the same thing, like 100 meters, because when you use the Cat6 cable, it's 100. Cat5 is the same thing.
Yeah. Basically, as per the Sri Lanka, I mean, as per the world standard, always we keep 100 meters between the switch and the end device.
End device. Yes.
So again, you're going to connect it like that, NVR and PoE. Definitely, maximum distance would be 100 meters. And next thing, I would like to talk about something to happen in the future. Let's say now in your session, you discuss about this IP version 6 also. This is actually one of my question. Now you said in 2010, this adaptation started, like IP version 6.
Yes.
In Sri Lanka, even though it was originated somewhere around 2000. You mean what happened during in order to come up with this statement? Physically, what had happened out there in the industry? You mean there are devices which are running on IP version 6? So what really happened in 2010 in terms of changing from IP version 4 to IP version 6 in Sri Lanka?
It's actually, I must say that we had a separate IPv6 day actually on 2012. So in that case, the SLT, the Mobitel, Lankacom, and few other ISPs have enabled the IPv6 to their websites only at that time. And then we had discussions, we had a seminar, webinars, and it's a 2-day sessions actually. At that time, we were able to up and running all these websites in IPv6 environment, and that's the initiation actually in Sri Lanka. Then obviously there are several discussions happened to enable the 4G, enable the IPv6 to the 4G environment. Now, when you are dealing with the any kind of 4G suppliers, like specifically Mobitel, Dialog, and then other service providers, when you're using the 4G environment, they will be assigning the IPv6 to your end devices as well, laptop. So this is where we are right now in. But unfortunately, when it comes to corporate network, no one has adapted the IPv6 yet. That is, to be frank, that is the truth.
So what will happen in the future? Now, that is the current status. I know, despite this, all the economic issues, this and that and all, you mean, are we in a process of transferring or kind of a transient period between, in terms of Sri Lankan countries? I don't know, in the world, a lot of things are happening. But what is really happening at the ground level when it comes to changing from IPv4 to IPv6?
In enterprise networks, we are not actually ready to for these migrations. So we're still surviving with the IPv4 environment. But of course, the ISP level, so they have already migrated end users to the IPv6. But even still, they have not migrated their infrastructure to the IPv6 environment. They are still running like, if you look at the adoption rate in Sri Lanka, like if you compare with the Asian countries, so we have the adoption rate of 0.002% of the adoption rate in Sri Lanka. Whereas India, if you look at, they have the 0.1% adoption rate. So just imagine the comparisons. So we are actually far more behind this particular technology.
Okay. So, however, when it comes to the ELV system, since the number is very less, like, as you mentioned it several times, we are mostly far behind 256 devices. So I think we are pretty much comfortable with IP version 4 for maybe for another 2 or 3 decades. Do you
Exactly.
think like that?
Yes, exactly. Because definitely we can survive. We can survive for the next. And even there is a one concerns like if we use the IPv6, we have told you that IP version 4 having a public and the private IP address. Since the IPv6 having lot of IPs, like it's a 128-bit address space, like we can survive for the couple of centuries with this IP version 6. Therefore, whatever the IP address assigning to the devices, those are public IPs. So we are having a lot of security issues because each and individual devices we are exposing to the internet.
Yeah.
So that's the
So
issue.
you have to think of all the security encryption level to a great extent. But
Exactly.
during our lifetime, that won't be a problem. So all the ELV engineers, you don't want to worry about that. And there are a few questions again appearing. I think all the audience apparently very enthusiastic about your presentation. So thank you very much for creating this. When it's come to small scale PA system, is it cost effective to go for IP based system? What is your opinion?
PA system in the sense,
That means public addressing. I think I have to clear one thing here, Mr. Suran. Now, public addressing system where you inject, where you start broadcasting messages around the building. Now, this was to
right.
be kind of an analog system where you get the cable, 2-core cable 2-core, 4-core cable starting from the amplifier and goes to each and every speaker. Now, this has been adapted again IP technologies where you can connect this all the amplifiers through the IP network. So, but still the speaker remains in the analog cable because you may have sometimes 1,000 around speakers in a facility. So having IP connection for each speaker will not be practical.
Yeah.
Now, I think answering to this question, we have to do a proper cost-based analysis based on the configuration. If you are going with IP system for each speaker, definitely you have to understand at the other end, provide the network connecting for each and every speaker would be very costly in the current context because having all the switches and all. But instead, what you can do is all the central component, like all the amplifiers, could be connected with the IP network. Still, the speakers will be in the analog connection. I think that would be the most cost-effective methodology. Anything else that you have to add?
Yes, that is actually quite correct answer. Like we have to do the cost benefits analysis, and so I'm not think like it might be worth for the IP based systems if you go with that one.
Because if you go with I don't know how many speakers are there. Every speaker having IP connection would be very expensive as per the current scenario. So my recommendation in a situation like this, you go with IP amplifiers. That's very convenient, so that you don't want to pull so many cable linking all the amplifiers. But you can have your speakers still in the analog network. So thank you very much for the question again. Fiber optic. Can we use fiber optic to overcome the 100-meter limitation of Cat6 cable? Is optical cable too expensive to consider an opinion? You partially answered this question.
Yeah. Basically, we can definitely use the fiber optic channels, cables to 100-meter limitations. But the only thing is the connection cable terminations, because fiber optic cables cannot be straight away plugged into the the Ethernet connectors. So we have to converters. So converters are pretty much expensive, as well as the cable layering and the crimping of these fiber optic channels. We don't have much technological people, like it should require separate expertise actually. So we have a lack of skills as well in this particular area. So that's the major concerns.
Yeah, as Mr. Suran said here, even though in order to overcome this distance issue, you are using fiber cable, but remember, the end device, whatever the end device that you are connecting, will not receive the fiber signal as it is. You have to convert that fiber signal into an electrical signal through another hardware. So for that hardware also, you have to pull another power cable. So this creates a lot of complications. So when you are doing a design in that case, try to avoid these kind of pulling cables, lot of cables here and there, because that would unnecessarily complex the situation. So there are many other ways to mitigate these things. Fiber will not be a solution from the God always in order to mitigate the distance issue. When you do that, when you install a fiber cable to mitigate the distance, definitely there will be another problem coming behind that, right?
Yes.
So you have to evaluate these both extreme and come up with the good solution. So again, thank you very much. That's a very good question. And I would like to ask this question in terms of, let's forget this other complexity, in terms of the pricing, Mr. Suran. I think as I have heard right now, the copper prices are fluctuating very much in the industry right now. I think fiber cables are getting cheaper compared to copper cable. Any input in that case?
But yes, the cables are getting cheaper, but the only thing here is the devices that we need to do, because whenever we are terminating each and every fiber communications to each and every device, network device, so we should have a switch with the necessary fiber ports where we can communicate, like terminating the switch environment. So that is pretty much higher than the layer 2 normal switches. So it's the cost wise, the cable, obviously that is quite correct. Like copper cables are the fluctuating the prices, and it's definitely going up. And but still the other device prices are the major concerns that we are having.
And as Mr. Suran clearly said, when you are doing a design, try to reduce so many converters and so many electronics in between. You have overcome the distance issue, obviously, by having a fiber cable. But at the latter part, when it's come to the maintenance stage and all, there will be a lot of troubles coming after, because now you have to look after all the fiber converters, and their power devices are there, their cable should be looked after. So try to minimize using fiber cable unless you are going in for the backbone cable. But for the terminal link, when you are using fiber cable, please be careful.
Exactly.
That would be the ultimate solution if other option doesn't work. Widespread use of NAT and subsettings will keep IP version 4 going for few more years. Another gentleman has contributed here.
Yeah. That is quite correct, actually. That is exactly correct. So we can survive with the netting and subnetting for a couple of decades, even with the IP version 4.
Yes. So as I mentioned before, during our lifetime, still be with IP version 4, right?
Yeah. Yes.
And next thing, Mr. Suran, as you clearly highlighted, this Class A, Class B, Class C IP network type. Now, mostly we are going with, I think it's Class C, the last three digits. That's what we mostly work with. But let's say due to the increase of the devices, sometimes that could happen even. Actually, I have seen certain actually I dealt with one CCTV installation that had 128 CCTV camera, and then you added another number of access control devices to the same network and DDC controller from building automation system, all packed. But still, I was in the within the safer range. But just imagine in a scenario where if we have to go from C to B, at the latter part you are connecting two buildings or something. Let's say imaginary scenario. Yeah. Can we change this whole IP address? Should I start from the beginning again and change the whole IP network?
No, if you have already decided in the Jagat, like it's not possible to do again migration. So you have to change entire thing from the beginning. That has to be from the scratch. So there are no other ways. Otherwise, what you can do is you can have another network and then merge it. That is possible.
By merging, by routing device, you can merge these two devices.
Yes.
And this is very important for engineers also. I even few of my previous installation also, when we were doing the schematic drawings for CCTV, access control, and all the ELV devices, we used to put the IP addresses also. Even at the design stage, we made sure what are the IP address would be assigned to each and every device. So the people, at the maintenance stage, they were very clear on, what devices that they are dealing with and what are the IP addresses that they're gonna use there. And as you mentioned also, password and everything was mentioned in a separate document, of course, not in a public document. But these are the very important practices that you have to maintain, establish, especially when you are dealing with IP related devices. If you lose your password, remember there is no way of recovering the system again, because if it can be recovered, it's not a security system.
Yeah.
Importance of password. Anything, Engineer Soran, that you have to add there?
Yes, exactly. Like that is actually a exactly good practice and exactly what we are expecting to do. Like from the design stage, you need to put the all the IP addresses. That is actually quite correct. Even we have seen like this has been not practiced even in the network engineers as well, because they are maintaining a lot of servers in the data centers, but they don't have IP addresses. So they are in a struggle to find the IP address when they want to do troubleshooting. So but if you can do that one from the design stage, so that will make definitely ease your life. That is quite correct. And the other thing is like whenever if you have forgotten the password, the only way is you need to do the reset. So no point of then your data will be lost once you do the reset. So that's the major thing. That is quite
That
correct.
resetting is a hard. Usually, sometimes you may have to take the camera out and press a button inside the PCB.
Yes.
So those things are little, you have to be little technical savvy in order to do those kind of things.
Yes.
So by having the password on your hand, you can get these kind of thing avoided.
Yeah.
And yeah, I think any other question if you have, this is an ideal time related to even your domestic network. If you have any issues, we can sort them out with the help of this expert that we got after long time. And I want to highlight one thing there, Mr. Soran. Now, if you lose your password, let's say due to some reason, I have seen that also. Due to some reason, if you do not have your if you do not have your IP addresses right now, let's say the entire network remain kind of gray area, you don't know the IP addresses. In that case, what you can do is this particular product manufacturers have issued some network management software. Let's say if you are using XYZ cameras from some country, they would issue a special free of charge network management software by connecting your laptop to the CCTV network and running this software. You can get all the network, all the IP addresses of that CCTV cameras only, right? You can't obviously get the IP address of other devices connected, but at least you have to have some understanding on the initial numbers of the network, right? Otherwise, definitely your laptop will not be recognized by the network there. So you have to have initial, as Engineer Soran said, initial numbers have to be there. But then you connect your laptop with the network and you can extract this all the IP addresses available in the network. But as Mr. Soran clearly said, if you lose the password, definitely you have to go back to the device and reset it. And remember, you have to do all the settings, because it goes to the default setting. You have to change everything from the stretch again. So that's why the recording is very much important. So any other question, ladies and gentlemen? Yeah. I think people are very much into fiber cable. Do fiber cables protect device from surges and lightning strike?
Yes, exactly. So definitely the fiber cables definitely protect the devices from the surges and the lightning strike. That is, there are no doubt about it. So that's actually the benefit that we are getting when we are layering out with the fiber cables.
But remember, the end device converter need power supply. So you will have to pull another power cable along with the fiber cable to power the end media converter. So even though the devices are protected, definitely your power unit will be burned due to the lightning and other surges if it is exposed to such scenarios. So please, that's why I told you everything has both sides. When you avoid something, there must be another complication appearing at the other end. So those are the basic questions actually we had to discuss here. Actually, those are the questions are appearing here and there here. And but before winding up, I think we are almost at the time also. What are the advice that you can give us, Mr. Suran, in terms of improving the quality of the system? I think you highlighted few things, but once you go through this question, you would have seen a different angle of our engineers also, because there were a lot of questions appeared. So any advices that you can tell us in terms of selecting these ELV devices and improving the stability of the network? You clearly highlighted this was several times. Actually, most of the problems are not due to IP address, not due to password. Actually, it's due to the hardware component. Your cabling. I have several times noted this. Cables are the bigger problem in the connectivity is the bigger problem in network issues more than any other thing.
Yeah, yeah.
So anything else that you have to add, Mrs. Suran?
Yes, basically, the when you are dealing with these IP-based systems, the first thing is like the cable should not be rolling and like tied to the cable tighters, and don't do those things. Of course, that will lead to losses the images and then damage their cables. So always like keep your cable in a lengthy manner, so where you can safely deal with it. And then again, when you are dealing with the layering out the cables, so just keep in mind on the distances, and as well as when you are trying to send those through the ducts, so be careful when you are sending it, because that like when someone is again layering the cable, so that might damage the cables as well. So because in a building, of course, the construction environment, that same duct will be used different people. So not even the engineers, but also the IT people also going to use it. So then they will use the same thing, and then so better to send, even you are sending through the ducts, so if you can use the casings to cover your cables, that is quite good. And then again, when you selecting the devices, always be conscious on the cost, as well as don't go for if you have any doubt on these things, so you can reach to any IT people in your environment, and then get the advice from them as well, because they definitely will support you to engineers to support to get the proper devices for the building environment. So that is also there. So these are the things that what we really need to remember, what we really need to do when we are going for a IP-based ELV systems.
Yeah. And while you were explaining that, there was another thing came into my mind. Now, the biggest worry most of the consultant and most of the engineers to go ahead with IP-based system is that the complexity that would arise when the trouble comes. Basically the troubleshooting the system would be very difficult. You have to have some sort of expert in order to troubleshoot an IP related system, because if it's an analog system, the cable, it directly comes from the from the CCTV camera, and you connect into DVR. If the cable is broken, the videos are not there. As long as the cable is there, the video is there. But obviously, as you explained, IP system would have more than that. It's not only the physical connectivity, there is something related to IP addressing as well. So let's say you are given a system which is not working properly. Now, what is your advice for an engineer to troubleshoot? From where we should start as the very first approach? From which point we should start? Like anything based on your past experience that you can share with us?
Yes, the first thing is we need to check the cable connectivity. Like we can use the cable tester. That is the very first thing that we need to do before checking IP addresses and everything. Cable testing part. Like we have we can have a separate cable testers, and then the first thing is we need to check the both ends by plugging this cable tester, and whether that is properly like sending the signals 1 to 8, 1 to 8. So if that is okay, that means there are no connectivity issues in between the NVR or the NVR with the CCTV cameras or the access control systems, ELV devices. Then, of course, the second thing is that we need to consider very much about the IP address. That is the second part that we will be playing with. So if you check those things, definitely the issue will be either the cable connectivity or the IP address. Those are the two things that the mainly in summary, those are the two errors that we are getting: IP address configuration error and the cable connectivity errors.
And Mr. Suran, now, there are a lot of product versions are being introduced, especially IP industry, the industry, which is being evolved so rapidly compared to other industries. You get one version today and within another few weeks time, there's another version coming out. And the firmware and software of this, most of the hardware components are also changing. Now, I have seen instances where like, even if you're having a switch at the access level and the distribution level, sometimes due to this version issues, even though you place your IP address and your connectivity properly, I have seen sometimes due to this certain protocol issues between switches at the access level and distribution level, there may be some issues arise. So to be honest, in a scenario like that, we are very helpless. Any advice, Mr. Sashika Suran, in that case?
Yeah, basically, when you are dealing with these devices, so what we actually recommending is to purchase the devices with the same product owners, like product vendors. Let's say if you go for ABC vendor, like we have to purchase all the devices from these ABC, because even if you look at the any kind of ELV system providers, they provide entire thing, like end-to-end solutions. So we can purchase from them. So rather than going for a different providers and purchase the products from the different, obviously there might be incompatibility issues, like compatibility issues, since the vendors are different. Like if differs the vendors, definitely that will might impact. So the recommended is when you go for ELV systems, purchase the entire sets from the same vendor.
That's a very good input.
Yeah.
You have one switch from one vendor and the next switch which is connected to the same switch from another vendor. Definitely there will be protocol incompatibility that might that might give some trouble at the operational stage.
Yes.
So I think there's a one question again appeared here. How about EMC compliance requirement on this ELV cabling and equipment to abide? Any electromagnetic compliances?
I'm not exactly quite sure about this compliance, Engineer Jagat. So because it's like this. So this particular environment does not provide any compliances. Like whenever you use the ELV system, that does not, like say for example, if we purchase something like just imagine like when you go for a cloud environment. So the cloud environment specifically stating that they have complied with some compliances. But when you go for this kind of this, since these are the physical devices, they don't tell anything about the compliances. So if we want to go for a compliances, we have to comply in a way that it is satisfying their requirement.
As you clearly stated, especially when it comes to the ELV installation, try to keep your devices, all the ELV devices. It could be your switch, it could be your public addressing system, it could be your fire alarm system, CCTV access control, isolated from the heavy electrical cabling. Definitely the whole system will be jeopardized if you keep all the cable close to each other. Because it's not end of the day whatever your compliances is, definitely it's physics end of the day. Your higher magnetic fields will definitely disrupt the signals, especially VSDs and other equipment are creating huge noises, electromagnetic noises that might disrupt the signal transmission in the system. So in summary, today obviously personally I learn a lot. I'm very enthusiastic in this subject, especially being an extra low voltage system engineer. Thank you very much for those all, especially the way you highlighted about the IP addressing and subnet masking and class A, class B IP addressing. In Sri Lanka, I believe that if the number of devices exceeded, definitely we may have to consult you again in order to connect these all the devices, because we are, for the moment, we are okay with 254 devices, but obviously if the number exceeds, we may have to go for different scenarios. Thank you very much for highlighting those things. And especially I like the way you highlight about this issues related to the cable. Is most of the time the complaint that we are getting is ELV systems are very complicated, difficult to troubleshoot. But at the end of the day, if you follow this very simple rule, as he clearly mentioned, the cable, as long as you have the physical connectivity, as long as you have mentioned the correct IP addresses, definitely the system should work.
Yes.
Don't worry, it should work. You know, if because these devices are very intelligent, they have made in a way that the communication could be established. So if you, as long as you maintain these few principles, definitely the system should work. So there shouldn't be any kind of reluctance from your end to use IP-based systems, IP-based ELV system. Please use them, because that's going to be the future. So thank you very much for highlighting these key points there. I think the entire audience, this audience comprised of engineers, especially building services engineers who are daily involved in ELV devices. I think nowadays everyone is using some sort of an IP address in their life, because if you are connected with your laptop, your mobile phone, definitely an IP address is there. So thank you very much for removing and eradicating this fear to use IP related devices today. I believe all the engineers, all the consultants, all the people who are in the building services engineering sector wouldn't think twice in the future to use IP based system. So again, thank you very much for this wonderful work you did for us today, and we all learned a lot. Looking forward to hearing and listening to you even in the future. With that, thank you very much. I'm wishing you all the best in your future endeavors. And back to the today's our engineer who is to do the vote of thanks. Thank you.
Thank you, Engineer Jagat.
Thank you, Engineer Jagat. Hope you can hear me.
Yes, we can hear you.
Yeah, perfect. Good evening, ladies and gentlemen. I'm Kaushal Patrina from Building Service Engineering Sectional Committee. Well, wow, it was quite an informative and interactive session. I believe that you all have gathered valuable knowledge about IP technologies and got few glimpses of future capabilities of building service engineering. As we are reaching to the end of today's webinar, I'm here to present the vote of thanks on behalf of the organizing committee. First and foremost, I would like to offer our profound gratitude to the guest speaker today, Mr. Sashika Surain, for his valuable time and enlightening us with his knowledge. Please accept the token of appreciation. And thank you. Yeah.
I hope you can see the token of appreciation.
Yes.
Yes.
Thank you very much.
This is the best we can do during this time.
Well, it's very much appreciated. Thank you very much.
Yeah, thank you, Mr. Sashika Surain. And then I would like to thank ISL staff for facilitating and arranging the webinar successfully. And then finally, yet importantly, our sincere gratitude goes to all of you for actively participation for this forum. Okay, before winding up, I would like to invite you for our upcoming public lectures and other events organized by the Building Service Engineering Sectional Committee for the session 2021 and 22. We will notify further details in future. Okay, well then, we are looking forward to see you all in next events. Wishing you a lovely evening without any hassles. Stay safe. Thank you. Thank you.
Thank you. Good night.
Thank you very
Thank
much.
you.
Thank you
Thank you very much.
Good night.
Good night. Bye.
Bye.